Hi, I'm Alex and welcome back to another episode of Each week I pick a topic I know a little bit about and we learn about it together. And today we're talking about something you use every single second of every single day and something that I actually work with. It's electricity. It powers your phone, it lights your house, it keeps hospitals running and the internet alive. And as much as I work with it as an electrician, I realized I still had a few questions about it. So today we're breaking down the science, the history, the infrastructure, and the future of electricity. At its most basic level, electricity is the movement of tiny particles called electrons. Everything around you is made of atoms, and atoms have three parts: protons, neutrons, and electrons. Protons are positive, electrons are negative, and neutrons are neutral. When electrons move from one atom to another in a flow, that's an electric current. Think of it like a water flowing through a pipe. The pressure pushing the water is voltage, the amount of water flowing is the current, and the size of the pipe, or how much it resists the flow, is resistance. Those three things are linked by one of the most important equations in physics, Ohm's law. Voltage equals current times resistance, or V equals IR. And here's something fun. When you flip a light switch, the individual electrons actually move incredibly slowly, only a few centimeters per second. But the electrical signal itself travels at close to the speed of light. That's why when you flick the light switch, the light comes on instantly. But understanding what electricity is was only half the battle. The real story is how humans figured out how to harness it. Humans have known about electricity in nature for thousands of years. The ancient Greeks noticed that rubbing amber on fur created a static charge. The word electricity actually comes from the Greek word electron, which means amber. And there's even evidence that ancient Egyptians were aware of electric fish in the Nile. They called them the thunderers of the Nile. But for the most of history, nobody understood what was happening. Then, in the late 1700s, things started to change. Benjamin Franklin proved that lightning was electrical in nature. His famous experiment in 1752 showed that lightning and static sparks were the same phenomenon. That was a huge deal. It meant electricity wasn't magic, it was a force that could be studied. In 1800, Alessandro Volta invented the first true battery, the voltaic pile, a stack of zinc and copper discs separated by cardboard soaked in salt water. That's why we measure voltage in volts. Then, in 1831, Michael Faraday made one of the most important discoveries in human history. He showed that moving a magnet through a coil wire generates an electric current. This is called electromagnetic induction. What's incredible about Faraday is that he had almost no formal education. He was a bookbinder's apprentice who taught himself science by reading the books he was binding. And it's his discovery that sits behind almost every power generator on the planet today. Every coal plant, every wind turbine, every hydroelectric dam, they all work because of what Michael Faraday figured out nearly 200 years ago. By the late 1800s, the question wasn't whether electricity could be useful, it was how to deliver it to people. And that's where one of the most famous rivalries in science ever began. Thomas Edison versus Nikola Tesla. Edison championed direct current, or DC. It flows in one direction, it's simple, and in 1882 his Pearl Street station lit up part of lower New York City. But DC had a massive problem. It couldn't travel long distances without losing enormous amounts of energy. You'd need a power station practically every couple of 100 kilometers. Enter Nikola Tesla. Tesla believed in alternating current, or AC. AC constantly switches direction, and crucially, it can be stepped up to very high voltages using a transformer. High voltage means less energy lost over distance. Tesla partnered with George Westinghouse, and what followed was the war of currents. Edison fought dirty. He publicly electrocuted animals to show how dangerous AC was. He even helped develop the electric chair, which used AC partly to associate it with death. But in 1893, Tesla and Westinghouse lit up the entire Chicago World's Fair using AC. It was the knockout blow. AC won, and it's still what powers most of the world's electrical grids. Funnily enough though, DC has made a comeback in recent years. Your phone charges on DC, solar panels produce DC, and many modern electronics run on it. So in a way, Edison and Tesla ended up both being right. When you flip a light switch, the electricity reaching your bulb might have been generated hundreds of kilometers away, just a fraction of a second earlier. It all starts at a power plant. Could be a coal station in the Hunter Valley, a wind farm in South Australia, a solar farm in outback Queensland, or the Snowy Hydro scheme, which is located in the southern part of New South Wales. Whatever the source, something spins a turbine, which spins a generator, which uses Faraday's electromagnetic induction to produce electricity. That electricity gets boosted to extremely high voltages and sent along transmission lines, which are those big metal towers you see running alongside highways and roads. In Australia, most of this happens through something called the National Electricity Market, or the NEM. It connects Queensland, New South Wales, the ACT, Victoria, South Australia, and Tasmania into one massive grid. It stretches over 5,000 kilometres from Port Douglas in far north Queensland to Port Lincoln in South Australia. It's one of the longest interconnected power systems in the entire world. Western Australia and Northern Territory, though, aren't connected to it. They run their own separate grids. When the electricity finally reaches your neighbourhood, transformers step it back down. That green rectangular box on the footpath near your house brings it down to 230 volts, which we can use in our power points and to turn on our lights. The whole system is mostly invisible to us. You flick a switch and the lights come on, but behind it is one of the most complex machines this country has ever built. It's hard to overstate how completely electricity has transformed civilization. Before it, life after sunset meant candles and oil lamps. Factories ran on steam. Communication was limited to telegraph and post. Then electricity arrived and everything changed. Electric lighting extended the working day. Refrigeration transformed how we store food. Radio and television connected people across continents. And then came computers. Every piece of digital technology you use is fundamentally a machine that moves electrons around in very precise ways. The same force that the ancient Greeks noticed in a piece of amber is now powering artificial intelligence. And yet, around 675 million people worldwide still live without access to electricity. The countries that electrified fastest are almost always the ones that develop fastest. Electricity isn't just convenient, it's the foundation of modern life. But electricity hasn't come without a cost. For most of the last 150 years, the majority has come from burning fossil fuels, and the energy sector is responsible for around 73% of global greenhouse gas emissions. So the shift to renewables is now well underway. Solar energy has dropped in cost by over 90% in the last 15 years. Wind power is booming. Countries like Denmark and Uruguay already generate the vast majority of their electricity from renewables. But the biggest challenge isn't generating clean electricity, it's storing it. The sun doesn't always shine and the wind doesn't always blow. So battery technology is the next great frontier. Tesla's big battery in South Australia was one of the first major grid-scale batteries in the world. It's since been expanded and has become a model globally. And beyond batteries, There's green hydrogen, pumped hydro, and even nuclear fusion, the process that actually powers the sun. Fusion has been 30 years away for about 60 years now, but recent breakthroughs suggest we might actually be getting close. If we crack fusion, it would mean virtually unlimited clean energy for the entire world, and that would change everything. Learning about electricity actually made me realize something. We take it completely for granted. You and I flick a switch and a room lights up, but behind that action is 200 years of discovery, rivalry, engineering, and infrastructure. From Greek philosopher rubbing amber to Franklin's kite in a thunderstorm to Tesla and Edison going to war. Electricity isn't just energy, it's the invisible force that built the modern world. And that, my friends, is electricity. Please like and subscribe if you enjoyed the episode, and I'll see you next week where we'll get the chance to learn about another topic. Bye for now.